In this next one, it says a circle with center at 3, 5 is tangent to the x-axis. And the hint that's given here is that if it's tangent to the x-axis, it means that it only touches the x-axis at one point. All right, if you're familiar with tangent lines as they relate to circles, remember tangent lines kind of glance off the outside of this thing. All right, so I still want to find the center and the radius, but my approach to this might be a little bit different than in some of the previous examples. What I'm going to do this time is I'm going to draw a graph. I've already got the center, so I'll fill that out a while. It's 3, 5. I'm going to draw a quick sketch of this thing. All right. So if I draw a quick sketch of this thing, I've got my center, and my center is at 3, 5. So I go over to 3, and I go up to 5, which is right here somewhere. And then I want to just draw a circle that just touches the x-axis. So what I end up with here is I end up with a circle that just kind of glances off of this thing. So my circle kind of looks like this. All right. So that's the bottom half of my circle. You can imagine the top half of my circle. That's not very good, so I'm going to get rid of that. But we can see the bottom half of that circle. It's almost like a tire that's just touching the road, and it only touches at this one single solitary point. All right. And so what I have here is I have 2 points. So I could treat this like the previous example, where I have the center at 3, 5, and I have one other point that it goes through, which is right here, which is the 3, 0. And I could go through and find the distance like I normally would. But since I already have this graph, I can see that these two points line up. I can just count the distance. And if I look at 3, 5 and I look at 3, 0, the distance between the two, simply by counting, is 5 units. All right, and so now what I have is my center. So now what I have is my center and my radius. So I'm just going to plug these in. So I've got x minus h, which is 3 squared, plus y minus k, which is the 5 squared, equals r squared. And since r is 5, r squared is a 25. And that's it. Okay, so just like with our parabolas, sometimes these are easier if we just draw a quick sketch and we can kind of see what's happening. And it makes this problem much, much easier than actually using any of my formulas. And we had a couple cases with our parabolas that were the same way. Okay? The next one's going to be very similar. I've got a circle that's tangent to both the x and the y-axis, and it passes through the point -2, -1. And this one's a little bit tricky because there's not a real solid mathematical way of approaching this. We kind of just have to draw a quick sketch. I need the center, and I need the radius. And I'm going to need a fairly accurate sketch here. So I'm going to come over here and draw a quick sketch of this thing. And so what I have is that we're going to pass through the point -2, -1, which is going to be right about here. Let me draw that in another color. So I know I'm going to go through that point, and I know I have to be tangent to both the x and the y-axis, which means I can only touch each of those. So really, when you look at this, you kind of have to just get a feel for this. And as I start to sketch this thing out, I know I just have to touch at this axis. I know I just have to touch at the other axis. And so this thing kind of fills itself in. If I have to just touch at each of those axes, I have to have a circle that looks like this. And so, and that graph is just a little bit off, and that's because my my values aren't spaced out properly. I'm a little bit off. I made my x values a little bit too wide. But we can kind of see where the center of this thing is going to have to be. It's going to have to be here at -1, -1. And now I can see that my radius in every direction is a 1. Okay? And so just by drawing a quick sketch of this thing, I can see that the center is -1, -1. I can see the radius is 1. And now I can write the equation of this thing. X minus h, which is like a +1 squared, plus y minus k, which is like a +1 squared, equals r squared, which is 1 squared, which is 1. Okay? And so this is kind of a unique situation where it's really easy to just kind of see it once you plot that point. You know the circle has to pass through that point, and it can't cross over the x and the y-axis. It just has to touch them. There's only one circle that's possible for us to draw in this scenario. Okay? If I take a look at this last one, I've got a swing set here that's got a chain length of 8 feet and hangs 2 feet from the ground. There's a 6-foot tall fence 7 feet behind the swing set, and I want to know if a child swinging on the swing whose feet just touch the ground, will they be in danger of hitting the fence? All right, so I need to know if I need to move this thing before somebody gets hurt. So what I'm going to do is I'm going to draw the swing set, and I'm going to do my best here. That is terrible. I'm already doing a poor job here. But if I draw my swing set, so I've got a little A-frame swing set here. All right, and I've got a chain that hangs down for the seat. A little swing on it. And that's just a little bit above the ground. So we've got a 2 feet clearance right here before we hit the ground. And we've got a child that's sitting in this swing, so this child's feet are going to scrape the ground. And then I have a fence that's behind this thing. So if I draw my fence, I've got a 6-foot tall fence right here. And I want to know if, as I start to swing on this thing, if I'm going to hit the fence. And really what I'm doing here is I'm creating an equation that's really a circle. And so as I think about this, the chain itself right here is 8 feet. And then it's another 2 feet before we're hitting the ground. And that kind of gives us the space that we have in terms of where this thing is starting to swing. Because as we start to swing this thing, the circle is going to have a natural progression this way and this way. So really, the center of my circle is right here. And I want to know if I've drawn the circle accurately, or if maybe it's going to follow a path that's more like this, and we're just going to miss that fence. I don't know if we're going to be safe here. So what we want to do here is we want to write the equation of the circle. And as I stated just a moment ago, the center of this circle is right at the top of the swing set. So this is the center of the circle. And what I have to do is I kind of have to fix this thing to an XY coordinate system, all right? So I'm going to draw an XY coordinate system right over top of my picture. I'm going to make this 0, 0. I basically get to choose where I put 0, 0, where I put the origin, and I'm going to put it right here at the center of my circle, all right? And that's important because in terms of writing the equation of this circle, I know that the circle is going to pass through this point right here, and the center is at 0, 0. So if I have a center at 0, 0, and now I can just count the radius. The radius is 10 units from the center to where I have to worry about in terms of the outside of the circle, where the bottom of this child's feet are going to be. So the radius here is 10. So now when I write the equation of this circle, the equation of the circle is going to be an x squared plus y squared equals 10 squared, which is 100. And now I want to know if they're going to hit this fence. Essentially what I'm looking for is when I look 7 feet back, right here, I'm essentially counting the x values. This is 7 feet. So basically, I'm going to count back to 7 feet here on my coordinate grid. So 7 feet would be right here. So essentially, I'm looking for an x value of -7. I want to know, where is my circle going to be at -7? What ordered pair am I going to have here? And so what I'm going to do is I'm going to kind of do an xy chart here. And I'm just going to find the value of y when x equals a -7. So I'm going to plug this in. So I've got a -7 for x. And then what I have here is I've got a 49 plus y squared equals 100. I'm going to subtract the 49 from each side. I'm going to solve this for y. So I get y squared equals a positive 51. And I'm going to take the square root of each side, and I'm actually going to plug this in and estimate it as a decimal, just because I want to plot this thing, and it really doesn't make much sense to leave it in terms of radical form at this point. So it looks like I get a y equals 7.1, but it's not just a 7.1, it's plus or minus 7.1. Because remember, the circle is going to have two ordered pairs back here, so -7, 7.1, and -7, -7.1. And so what I have in terms of my circle that's being drawn here, I know I have this point. I know at -7 I'll be down at -7.1, which looks like it's going to be hitting my fence at some point here. And I also have the ordered pair at -10, so it looks like that coincides with my circle. Also have the ordered pair positive 7.1. And so really what I need to do is I need to narrow down the ordered pairs for my fence here. And so when I start to count around this circle, like if I use this ordered pair down here, this is the ordered pair 0, -10. The bottom of my fence right here, that would be the ordered pair -7, -10. And then the top of my fence, is still at -7 in terms of the x. But in terms of y, well, it's 6 feet tall. Well, the bottom of the fence was at -10, so 6 feet tall is going to put the top of my fence at a -4. All right, when I graph this thing. And so when I think about the ordered pair that I got for my swing, the -7, -7.1, I just want to ask myself, is the -7.1 between the -4 and the -10? And it absolutely is, which means this circle is going to go right like this, and this kid is going to slam right into this fence if I don't move this swing set. Okay? So the swing set needs to be moved because the child is in danger at this point. So I'm going to have to move the swing set a little bit further away from the fence. Okay? And so we figured this out just by writing the equation here and then plugging in a value to see if it falls in terms of the ordered pairs where the fence might be. All right?